Hey guys, there's another tutorial. It's similar to what we did on the 2D truss, but now this one is going to be a 2D frame, which means each of the loads, they are not pinned, but they are actually rigidly connected as a connection that can transfer moment. So this is looks like a truss, but it is actually a frame. As a result, each member will develop some bending moments and some shear force, and of course there's going to be some axial reaction as well. But let's see what we need to do. So first of all, you select this point, and probably don't do that. But anyway, let's take a look at this guy. So we right click on it. You see the release end. Basically, it means that the T is the torsion, and M2 and M3, which is the bending about the other two directions. So basically, three bending moments, they are released, which means they are not constrained. So as a result, if you do the analysis on this one, there won't be any moment transfer through this guy. So it'll be purely just bending. Excuse me, axial forces. So it's a bar. But what you can do is that you can double click on it, and then you say, okay, I want that, or you just say no release. So you see, then the releases becomes like none, and then it becomes a what we can call it a beam with the square bar cross section that we just defined, or anything like that. You can kind of repeat this process for all the other members, but really, there's got to be a better way to do this. So actually, it is true, because you don't want to kind of click on like 1,000 members to modify them one by one. In SAP 2000, you have a interactive database editing. It is like the output we have, but you just go. So if you want to change something, say you want to change the frame, the end releases, that's what we call it. So there's end release table, see? So you can kind of just go away with it, and I only did the selection, so it only select that. So I see clear selection. I'm not selecting anyone. Go into here, then we do the same thing. Now you see we have all the I don't know why they can't do this. Okay, so basically you have all the frame members, and then you have all the releases. It's either yes or no. You can see almost all the members, they have been releasing those M2, M3, and the T, M2, M3 at the I location, and those at the J location. So in order to kind of just get those, so you can do this, get rid of those releases. You can copy, then paste, and then you can actually do Ctrl C and Ctrl V, Ctrl V, Ctrl V, and now you see apply to model, and then done. You can't see any difference here, but if you right click on any of the members, you see the releases, there's none. So which means they're not released, which means they're fully connected. Now you can actually do the analysis. Let's do it. See the analysis options. Let's do this guy. So this is a 2D frame essentially. Then you run analysis. Run now. Okay, here it gave us the force, of course, and now you can do the moments. See, I mean, those moments are minimal here because I mean the way this is configured, it is pretty much a truss. So, but you do see a lot of moments going on here. So if you're doing a really a moment frame, something like that, the moment's gonna be dominating. So if you do, you can also do shear. So like the axial force, in fact, it is like force 1 1, which means those like 2 2 3 3, they are not the force YY or force ZZ. They are actually those 2 and 3. They are the local axis of those frame. The same thing with moment. You can look into it later, but if you do force shear 3 3, which is shear out and into the plane, it's nothing. So that's all I want to talk about the 2D truss, and there's another pretty cool tool. It's only available in those like white background type of thing, and then you can do the extruded view and fill objects. They cannot do it for the deformed. Okay. Huh. Well, it doesn't work out very well. Anyway, I'm gonna show that figure. It's basically just give you a rendering of the 3D model. But since this is the cross-section that we defined, the program probably cannot do that. That's my guess. Let me just try it just one more time. Oh, well, here we go. Yeah, see, it's kind of pretty cool to look at. But so that concludes this tutorial, which is very short compared to the last one. But anyway. Now you know how to do the 2D truss and the 2D frame. For our project, we do want to just do 2D truss because that's what your MATLAB program is capable of doing. So make sure when you draw those lines, you use pinned connection when you draw those lines, and then you just go from there. Okay, I think I am planning to do another one just to show that you get show you the like a angle of roll. So I'm gonna do a 3D frame similar to the example you did earlier, but I will kind of focus on some specific things I want to talk about. And just before I go, I just want to kind of show you one more thing. Like we talk about when you do this say moment diagram, then you can click on it and right click on it. It'll give you this, and then you can just drag your mouse. You see the moment at any place here. I mean, at any cross section. It's linear interpolation, but I mean, this is good enough. Alright, so as for the design, you typically you just do the kind of combined moment shear and axial forces design for those type of things. But I mean, this is not a design class. Okay, that's all for now. I will post another one on the 3D frame soon. Thank you.